So our next talk is coming from Kevin about Triforce, about repository management. Kevin, take it away.
Hi. Yeah, so this talk was originally called Triforce. So you're in the right place. This is repository management. I'm Kevin Mittman. I work at NVIDIA as a senior software engineer. Here's a short bio, and here's the agenda of what we're going to talk about. So let's get right into it. So before we start, I just want to mention that the scripts that are mentioned near the end of this talk are available on GitHub. So you can go here or scan the QR code. So let's get into it. So I'm going to specifically be talking about Debian RPM package repositories. I know we talk about a lot of different package formats at this conference, but we're talking about specifically apt, DNF, yum, zipper. They all use metadata files to determine what packages are available, how to resolve the dependencies, etc. And whenever you add or remove, although in this case we're only talking about adding packages, you need to regenerate this metadata. Just adding the package itself doesn't actually do anything. And you need to have all the packages in one directory in order to regenerate this metadata. As you grow to thousands of packages, this becomes a problem. So problem statement, updating the metadata does take a while. It's network IO intensive if you need to copy files around, which you probably do. And it's CPU intensive because guess what? You need to have checksums, MD5, SHA-256, etc. For each of these packages. And when you have either a lot of files or some large files, a few gigs packages, those take a while to actually calculate. So Project Triforce, what are the goals? 1, reduce CPU overhead by only processing new or modified files. So anything we've already processed before, let's try to ignore that. Let's just avoid the file copy. Copying files around takes time. It uses up a lot of storage. So wouldn't it be great if we could just have our work directory that we're going to use for generating the metadata be the mirror of a repository, a snapshot, union with the new packages. And also, we want to be able to do on-the-fly merges for our whatever release vehicle we use. Be able to have, n number 1 to n releases go out at the same time. So let's talk a little bit more into detail about how the actual underlying metadata actually works. So let's talk about Debian first. So when you run apt-get update, that's going to go ahead and check for each repo that you have enabled. It's going to check for in-release or release file. We're talking about release files here specifically. So you can see here on the right, this is an example of what it looks like. You have the file names, packages, Packages.gz. You have the file size, you have the checksums, you have the timestamp when this release file was last updated. And then you also are going to want to sign this release file with your dpkg key, and you can very quickly verify that, and that's what the package renderer does behind the scenes to make sure that, yeah, this does match up. It's also going to check to see if this release file matches up, right, because it has the checksums and everything of these files that it's referencing, if those files match up with what it saw in the release file. So what's in the Packages.gz? So, it's a gzip text file. It has blocks for every package. It's not really like a YAML or JSON, but kind of close. So you have key value pairs, package name, for example, and you separate each block with a new line. So this is basically what it looks like here. You have your dependencies and all the other information. But here's the sharp edges, or here be dragons. What I found is the order of these package blocks matters, at least in some edge cases. And so what we've done for the script that we're going to talk about is have all the blocks appended to the end. I tried going the other way around, and that didn't work out too well. So it seems to be chronological order works best. And there's also, this is not really a gotcha, but it can be. There's a convention to the order of those key values. It's generated by dpackage. So if we go back to this slide here, see like you have package version architecture. If you use other tools, I know there's some other tools mentioned at this conference. For example, CMake or any other thing that's not dpackage, they might not follow this convention. They might use like alphabetical order or anything else. And so there can be some gotchas there depending on how you're parsing this file. So just keep that in mind, that there is a kind of a convention when you generate packages, Debian packages using dpackage. So while we're on the subject of metadata and repositories, I thought it would be a good opportunity to mention that if you see any errors like this, stale CDN, has mismatches or something like that, go ahead and report that to us on GitHub. Talk about that in the next slide, but also if you see like, signature is going to be verified, then probably need to import the GPG key. You have to do that manually on Debian and Ubuntu, which is currently done using apt-key as per the CUDA download page instructions. But that command is going to be going away pretty soon. So we're looking to, ext repo. If anyone works on that project, I love to chat about that. So, this is just purely for debugging purposes. If you find an issue, please go ahead and just leave a comment on this GitHub issue number 1 with some information to help narrow down what the problem is. So let's talk about the flip side of things, at least from my perspective. So you talked about Debian stuff. Now let's talk about RPM stuff. So Yum and DNF as well as Zipper, similar to looking for a release file, they're looking for repo.md.xml file as its entry point. And a little bit different is that rather than having hard-coded packages.gz file names for what it's pointing to, these files are unique based on the content. So they're the SHA-256 checksum prefix to the file name. So every time you add or remove files, those would change. And so that's a little more CDN friendly. It doesn't solve all of our problems because we are still overwriting the repo.md XML file. And, CDNs are great at write once, read many. And so there's a few other files here, primary file list, other modules, we'll touch on that. Similar to Debian, you sign this file. So you see it, look out for an .asc file. And that is going to help verify the metadata. But different is that while signing individual dev packages is optional for RPM, unless you have GPG check set to false, which you shouldn't do, all your individual RPM packages need to be signed to. And also different is that the client will go ahead and if it finds the .key file, it'll ask you to import the key. So you don't have to manually do that. You can just, say yes, or if you do DNF-Y, it'll just automatically do that. So again, this is a XML file here. It looks a little bit different, but same basic idea. So this is, similar to the Packages.gz file, where you have a bunch of XML tags, package tags, and all your standard information, dependencies, descriptions, etc. I do recommend using create repo_c for this. The old version is in Python, and it's not as efficient. For the Debian, we are going to be talking about a custom solution. And you might not see this very often, but this is a modules.yaml file. If the repository has modularity streams, so for example, Fedora 29 and newer, or RHEL 8 and newer, have this support for this feature. And this lets you do things that you normally couldn't do with just standard RPMs. And the metadata, you can say, okay, these packages belong to this stream. And you can flip through the streams. You can think of them like branches. You pick one. There's also modularity profiles, and you can pick one or more of those. Yeah. Anyway, you'll see this Python script here. This is the custom for NVIDIA, but same basic premise. Will generate these YAML files, and those get injected into your repo.md using modify repo. Again, if you have any problems, like for example, these things, please report them on GitHub. So let's talk about scaling out. So pre-pandemic, about 1.5 years ago, this is the size of the Qt repository. And by Qt repository, I mean several different repos, and these are specifically the ones that are active repos getting updates, was much smaller. Now we are approaching, a terabyte. So why is that? Well, we've added a lot of products to the Qt repository, so it's not just CUDA anymore. We have all of the things that used to be in the machine learning repository, like cuDNN, Nickel TensorRT, as well as new products. So what does that look like broken down? So you can see here it's broken down by repo. Some of the repos are quite large because they've been around for a long time, like RHEL 7, over 100 gigs. Some of the repos are much newer, like Debian 11, 3 gigs, Ubuntu 18.04, 62 gigs. And this is broken down by number of files. So, obviously more files, probably going to be larger, although, obviously not every package is the same size. Some packages are kilobytes and some packages are gigabytes. So let's talk about OverlayFS. So you have, various union file systems around, like AUFS. The great thing about OverlayFS is it's built into the Linux kernel. So all you have to do, really, as long as you have a new enough kernel, is mount. And what's great about mounts is they can cross file system boundaries. So you can have different disks. You can even have remote file systems like Samba shares mounted. And you can do these operations read-only, and then have copy on write. So your writes are going to be separated out. This lets you do non-destructive merges. As soon as you're ready, you've gotten your metadata files, you can just roll everything back by unmounting, and it's great. So one thing to keep in mind is that the order that you mount does matter. So you need to do things right to left. It's a little bit counterintuitive, but I've put it here in the diagram. Like the layer 3, layer 2, layer 1, and then in the lower directory and upper directory is where you're going to do your writes. It handles it automatically, so you don't need to do anything special. It'll just put the files that you've renamed or added new files to the upper layer, and then you can just grab those when you're done before you tear everything down. Let's talk about the actual scripts here. So I've got 4 scripts in this repository currently. We have the overlay script. In this, you start the intended use is you give it a mirror directory, and you add 1 or more directories you're going to overlay. And then it's going to determine, are there Debian packages in here or RPM packages in this directory, and it'll call the appropriate script. And so we can do this for all of those different repos that I mentioned in the previous slide, in one operation. So the Debian script here is a little bit custom. Previously, we were using apt-ftparchive, but we found that it's a little bit slow once you scale out to a few thousand packages. And so what I do here is a little bit of a naive thing, but by checking the key value pair for file name and size, and then parsing in our donor Packages.gz from from the public repository, for example, we compare the difference. Then we can see, okay, these packages in this directory are not known by apt or DNF because they're not in the metadata. So those are the ones we're going to process, right? So that was one of the first principles, goals of this project is only process the new files or modified files. And then we're just going to use standard commands, dpkg to get the metadata from the Debian package, do to get the file size, and the various checksum utilities. Then we append each of those as a new block to the end. The RPM side, create repo is great, so we just have a wrapper for that, and pass the appropriate arguments to run updates. And again, if it finds NVIDIA driver packages, it'll run gen modules. There's also a mirror script I've added in here, just to kind of get you started. It'll scrape a Debian RPM repository, for example, one of the CUDA ones, and go ahead and allow you to download each package and keep that up to date. So demo time. Hopefully I'm good on time. I go ahead and move to a new workspace. So first thing I want to do is record this using ASCII Anima. cd into the demo directory. Let's see what's in our Git repository. So 4 bash scripts. And we're going to go ahead and sure I can make the fonts bigger. How's that? And then let's go ahead and mirror 4 for AR64. I can type. And let's save that into the repos directory. Oh, wait, we're not here for hours because I've already done this, ahead of time because it's for a demo. So we're up to date. It detects 1,709 Debian packages in this repository. So let's go ahead and check this out. And let's ignore the Debian packages for a minute because we know there's already over 1,000. Be scrolling for a long time. There's also these other files in here, like our metadata files, Packages.gz, release. There's also these version.json files. These are very cool. So check those out when you have some time. So anyway, let's go and look at this into a little bit more detail. So we look at our release file, and we can see it was last updated on November 3rd, UTC's time. And let's look at the actual Packages.gz file. We can see that it knows about 1,709 files. Cool. So let's go ahead and look at through the power of demo magic, we have a set of donor metadata files. Normally it's supposed to be a directory full of Debian packages, but for our purposes, this is what we've got. And let's check this out. So we can see that this metadata file was last updated on November 2nd, so a day before what is currently live. So we've been able to go back in time. And let's check to see how many packages it knows about. It knows about 1,682, so a few less, right? So let's go ahead and actually run our script. And let's set the mirror directory to our donor directory, and we're going to overlay this repos directory. And we can see here it first creates a disk image, and then it will check comparison, and it's detected there was 29 packages that it needed to generate new metadata for. So that took a little bit slower today. Looks like 8 seconds. So let's go ahead and look at that. So if we look at our release file, here's our timestamp. Oh, wait, that was just a few moments ago, so that's good. And let's go ahead and check this out. And there are 1,711 packages that it knows about. So let's go ahead and finally just do a comparison operator. Sorry. Always, goes better when you're doing a dry run, right? So we look at this metadata. This is the difference here. So you see a lot of versions say 11.4.3. So that was our CUDA 11.4 update 3 release that went out recently. So let's stop that and let's go back to the slides. So the ASCII cinema recording will go there. So obviously a short demo because we have a limited amount of time, but here's a little more data. So this is real data, so that's why the numbers look a little bit weird. You can see here in the green, this is using our script, and here in the gray, this is the apt-ftparchive. So it does take a little bit longer, not terribly long, when you only have like about 100 packages, but it gets a little bit more dramatic when you have a few thousand. So here is our script using no donor data, so just generating everything from scratch. It took 20 minutes to run in this directory, and it took an hour and 17 minutes to work with apt-ftparchive. So that's quite a bit of a dramatic difference. And then again, as we've shown in our demo, adding a few packages, and here's 111 packages using the donor. It took 21 seconds. Again, here 14 minutes versus 50 minutes, and again 6 seconds to add just a few more packages. So what else can we use this for? Well, so if you go ahead and make your overlay, keep your overlay around, and you make it accessible via your favorite HTTP server, whatever that might be, and then maybe you add in a transparent proxy. Now you have a portable staging environment. You can have your tests, add the IP address to of your proxy and the host name of whatever you're trying to redirect from. And now you can test your external URLs in your .repo or .list files without having to change anything, and it'll just work, and it'll redirect to your staging environment. And so you can see, what you're going to ship right, before you actually have shipped it. And then another use case is, say you have BTRFS or ZFS. These new file systems have the concept of snapshots. So you can take a read-only snapshot of the repository every time you do a release. It makes you very easy to do a diff between every release. You can see what happened. You can also do a rollback if you have to. Another thing is you can streamline your postings. So let's say you have a bunch of different teams that are releasing things around the same time. You don't really need to worry about coordinating because you have on the fly, you can say, okay, I'm going to update the metadata at the last minute and then post that. So you don't need to worry about accidentally unshipping somebody else's software or pushing something that maybe was only meant for testing. So by putting this at your end of your release automation, works pretty well. So I know we have maybe a little bit over, but just a few related things I've been working on, tarball and zip archives. So look out for these -archive files. There's also JSON metadata files that are there. They have usual things: file name, size, checksums, the license. And this is an initiative to have consistent format for third-party CI/CD systems, repackaging. Right now we have this for every component in the CUDA SDK, as well as NVIDIA driver. Other stuff is coming soon. We have our NVIDIA driver package templates up on GitHub for RHEL, Fedora, OpenSUSE, Ubuntu. Debian will come soon. I did a couple talks on RHEL precompiled. So if you're using RHEL 8 and you're using NVIDIA GPU, I highly recommend you look at that. And also a couple shout outs to some of my teammates working on official NVIDIA packages for Conda and for Python wheels. And anyway, the slides are up here, so feel free to scan this QR code. Is there any time for questions? Any questions? Oh, okay, sorry. Have you looked at repository like pulp? So I believe this pulp is the same as what is used as the base for Red Hat Satellite, unless I'm confusing this with another project. So I've looked at that, and it doesn't fully meet our needs, but there are other options that we're looking to as well, yes.
Okay.
Okay. I'll be in Matrix as well as GatherTown until the end of the day. So if anyone has any questions or like to chat about anything, let me know.
Excellent. Thank you, Kevin, for your talk. I appreciate it. And